The following content is provided under a Creative Commons license. Your support will help MIT OpenCourseware continue to offer high-quality educational resources for free. To make a donation or view additional materials from hundreds of MIT courses, visit MIT OpenCourseware at ocw.mit.edu.
The more we can measure volume, the more we'll be able to follow the recent law we got passed that says they have to prioritize the highest volume for climate hazard. So that's a new law. They've never had to do it. So now they need the information, and they've never gotten volume information, and they've only cared about explosion risk. The president of Eversource Gas, in a meeting recently, he was very talkative, and he started talking about how there's no research and development in natural gas infrastructure in the U.S., period. They don't do it, no one else does it. That they go to France, England, and Germany because they invest in R&D for this field. And they find out what's going on, and they're way ahead of us. They're way ahead of us over there. Which was really interesting for me to hear. And they, in that room, there was no doubt they have no idea what the volume is. They don't measure it. They don't document it. And from what we can tell so far, there's no acceptable norm of how to measure it. So there's these two really kind of kludgy methods to me. And then there's, we're trying to invent a method that's actually the utilities can go out and do because the guys on the ground have to do it.
You know what's kind of funny?
Yeah.
Is that we can find it when it's sort of naturally occurring and it's worth something to us, but we can't find it when it's going through our own system.
Yeah.
So there
it's
was
3 feet below the surface.
Piece of data on volume. Did you tell them about the Harvard study?
Yeah, I
okay.
did earlier. So we know how much there is from the top down, from the in the atmosphere. We know how much gas there is, but we don't know where the most that 5%, 5 to 7% of the worst gas leaks are. So we have to come up with a method to, when they're about to repair the leak, after they've pinpointed what they think is a high volume leak, how do we
verify that that's a high volume?
Yeah.
Do we have on that global data, gas in, gas out?
You know what? Yeah,
yeah, but it's
over time.
So that in terms of,
Yes, and it doesn't match the outside data.
Well, of course it shouldn't. Leakage is that, but how's that changing over time?
so the utilities have crappy data. They have crappy meters. They have crappy everything. So they have no. So your meter at your house is not a very good. If the temperature changes.
It's right plus or minus X, where X is too big a number.
The margin of error is huge.
What this is, just to give you, the idea that we've come up with after months of working with the utilities and ripping information out of them, is to use these two instruments. They've pinpointed, so this is at the point that they've pinpointed the high volume, what they think is a high volume leak. And in order to do that, they drill holes in the streets. They found, using this instrument and another one, they found that there's gas in the area. And they've stuck this with a probe on it into the soil, and they found sort of the leak extent, the area in the ground that has a lot of gas in it. And then they drill holes in the street. So maybe, let's say it goes from 21 Smith Street to 25 Smith Street. And then they drill holes in the street along there and use this again. They put the probe in each of the holes through the street over the pipe. Should I draw a picture?
But don't drill into the pipe, just over the pipe.
Over the pipe. And they stick this probe in and find out where the highest percent of gas is.
So they're working with a map of the pipes.
They usually have a printed out, like, sketchy little map with a line, and it's approximate. I've watched them do it. It's close. They kind of know where the pipe is.
They drill holes in the street. They take this thing and stick the probe in those holes and find out where the highest gas is, the highest percentage of gas is. And and then they excavate at that point because they assume the leak is right there.
Sometimes they admit it how often they're right when they do that. Like
they do not share any information at all of any kind.
All right.
They
Another mystery.
believe this method works very well, but anybody who's looked at streets, you'll see lots of like patches, right? When anytime so sometimes they screw up. How often, we don't know.
Go look at
So-
9 Wells. Just go look at it. They just repaved it and it's already.
So if they're confused, if say this is 100%, this is 100%, this is 100%, they don't know where the leak is. What they do is they use this. They stick that end down into the hole that one of these holes. They put a compressor in this side, and they open this valve. Or I guess it is open, so that 80 pounds per square inch of air is being blown across here. This is a hollow tube, so it sucks air up really quickly, and this plunger gets pushed down so that it's sealed to the stream. Does that make sense? So air is being pulled out really quickly. It's a vacuum, drags all the gas out of the ground. And that way they vacuum all the gas out from this entire area. And then they use the CGI again this thing to see where the gas is coming back up fastest. And that's where they excavate and fix the leak. Does that make sense?
Yes. I get
So
it.
we want to use this tool in a different way to find how big the leak is. So instead, once they found the leak, we want to take this and you put it in the ground, again, attach a compressor here, blow the air out, and put a combustible gas indicator here to see what the percentage is of gas coming out of it. By doing that, we will know how much the flow through, right? Because it's 80 pounds per square inch coming out of here. And we'll know the percentage of gas. And using that, we can get a rough idea of how big the leak is, how much gas is coming out, how quickly. Does that make sense?
That'll
This is a purger. We only learned about it on Friday. I am so excited to have it here.
Got a diffuser.
Diffuser.
The method that you described sounds like it will tell you roughly how much gas was trapped in the area that you were evacuating, which might not be adjacent to the leak.
Right.
It could travel and then get trapped.
So you have to wait for a steady state reading.
Sure.
So so the gas will pocket up underneath the pavement, right? Because gas is lighter than air, and so you'll get a sort of pool of gas right up against the pavement. And so for the first few minutes, you're going to pull out that residual.
Don't you also need, in the pockets, don't you also need to worry, I don't know, question, nature of that substance, whether it's sand, clay, dirt,
Whether it's
rock,
wet, whether it's dry,
what
the temperature
what
is.
the nature is of that
So
diffusing material.
to get an exact measurement, yes, we would. But the high volume leaks are 10 times bigger, or bigger than that, than the
So
low
you're saying
volume
that,
leaks.
that shouldn't matter.
So you got an order of magnitude difference, so all that stuff hopefully will be, we'll have to find out. But I think this method will work enough to get us in the ball field so that we can say high volume, not high volume. Higher volume, we just want to bucket the leaks basically, categorize them.
So, a question, they're trying to fix what will be categorized as high volume leaks, right? They're not trying to fix everything that they find.
Right, this law that got passed is simply to fix the high volume leaks.
Okay. So, so when they go and they do their testing, right, and they get a series of readings, they basically guess where they think the high volume is, fix that joint, and then they forget about what's 12 feet that way, 12 feet that way.
Yes, you mean there could be another leak? Is that what
Well, sure.
Yeah.
In the case of they pick the wrong one, then there's still a high volume leak there, and that doesn't get found until they come back to the same spot.
Well, but back up. How do they determine? Is there another step once they pick the highest volume dug to the ground, I watch them, a physical test of identifying a real leak. You know, pipe, gas spewing out at the actual leak once it's uncovered. Is that a standard process, or do they, I mean, to your point, I mean, there may only be one leak, but there's a physical identification of the leak once they decide to dig, I assume.
Yes, but we can, you know, so.
There could be 5 or 6.
We have to assume they somewhat know their job, so they'll find the leak and they'll fix it. And afterwards, a lot of these might be leak complexes,
Right.
which means, you know, many leaks along the way. In which case, the whole area, that 21 to 25 Smith Street, is a leak complex, and they have to fix all those leaks. So they should use this method to measure the emissions off of each one of those sub-leaks, and then add them up into one high volume leak. So the utilities use the word leak in a very different way than we do, which is like leak location. Then we will be adding up all the emissions, which means that this method should not suck the gas out of more than one leak, or if it does, we will have to figure out how to.
Yeah, I think it might. I mean, because I would imagine if you have gas pooling or you have multiple leaks, there's going to be some connection between them.
Yeah.
So if you create a volume vacuum here, it's going to start pulling from the other.
So one of the things we possibly can do is there's going to be somewhere it's just going to be one leak.
Sure.
And using back data, we can figure out what the average leak is, and therefore we can, when we have a leak location, a leak complex, we can hopefully figure out how much overage there is, how much excess gas we're pulling in from the others. Yeah, so the things I think we need 2 things. One is some sort of regulator to step this down so that the compressor coming at 80 psi in.
Well, the other thing is this says 80 psi, but the guys in the truck say their compressor is 120.
Yeah. So
That
some
doesn't
sort
mean
of.
it'll crank all the way up though.
And so how do we make sure because if we don't know
Okay.
the pressure.
If we don't have the known rate of speed across here, the data's crap. So, and we also don't want to vacuum up higher than the operating pressure of the pipe. So
Sure,
the
'cause
pipe,
then you'll just draw it out of the pipe.
right, and it will be increasing the leak and it'll be crappy data
Okay.
again.
All right.
Does that make sense?
Yeah.
So these pipes can be anywhere from 0.5 psi to that we're going to be working with to 60 psi. So 120 times. So that's a difficult problem on its own. So we need some sort of regulator that will not increase, that probably is going to be going at 0.5 psi. So we have to step this down enormously. So that's one problem.
Okay.
And I don't know if that's true, so I am not a scientist. So anybody who
I
wants
mean,
to.
putting 80 psi on that doesn't mean you're going to create a negative 80 psi vacuum, but there's a correlation.
Okay, so
It's just not like
what's the regulator here? How far do we have to step it down? What regulator? I need the doohickey that goes here to be able to step it down in a correct, in a way that it will not.
We need to control this.
Yeah.
And preferably just one setting. Because these guys are going to be like, you just turn it on, just do it. I got to go for lunch.
Without modifying this?
Yes, without modifying it. So it's going to be another doohickey. They're going to take this off, put the other doohickey in, and crank it on.
Because
Nothing.
if you measure psi here, right, then you're getting sort of a direct reading of the vacuum that you're creating.
Yeah.
Right.
So there's this
If
valve,
you-
but we don't know if this valve
Yeah.
is working.
But if you take the 80 psi that you're putting in, you can calculate what that vacuum should be. So that could be simply a lookup chart or something like that for them.
Yeah, we gotta have it so, the whole thing is to make it so simple, they just write down one number in the end.
Error proof.
And
They don't
you
get
gotta
them.
imagine, you've seen contractors out there, right? This is not their interest. They are doing this unwillingly, so we have to come up with a super, super simple method that can just bucket the leaks.
So there seem to be 2 techniques in the literature for volume measurement of gas. One is the chamber method, which is a closed sample and measured over time to get a flow rate. And the other one is the flow rate, which is the rate of air movement. If you know the speed of air movement, and then you take 1 point in. So the idea of this, we're actually going to be doing the chamber method on the leaks in the street, which is error. And the idea of this is to try to get a flow rate method measured. So maybe we also take some capsule, but they're very, very, very concerned. They're very risk averse. They're very concerned about any capturing of gas. So.
And that, like, I can't even tell you how unusual it is that they are willing to do this. This alone is a stunning step forward.
Are these guys employees of the utility companies or subcontractors?
Probably both.
Okay. Is there a possibility of kind of developing somebody, developing a corps of trained professionals who would then contract with the utility companies to do that?
So we're going to do a training, basically, with the utilities to teach them how to do the technique, but first we need to come up with the exact technique.
So why?
And that's like in 3 weeks, so we're on deadline.
And we're trying to figure out a way to incentivize it for the guys. We've been talking to them, and actually they're not all disengaged. There's a wide array. Some of them are actually pretty engaged. To be fair. It seems like we have 3 different ideas so far. Does that make sense? We have one, we just said, add sensor, what are we calling this part of the tube? Sorry? Inlet. Into inlet tube. 2 is no sensor, use pressure differential. And 3 is attach sensor
Output
to output. Okay, so each of these definitely have pros and cons. But that's where we're at, right?
Yeah.
Number 2 is also doing the sort of baseline measurements, correct?
Yeah, that's the pros.
Yeah.
We don't know if 2 works.
Yeah.
So
I would argue that if 2 works, that meets your operational issue better than anything else, because all you're asking them is to read this meter. That's the change in process.
So
Basically.
The good thing about 1 is that they see something that may alarm them, as opposed to, well, actually, if they do enough of the calculations, then they may see a pressure reading and say, oh, something's wrong. But if they see something new that says,
Yeah, no, I'm with you.
the red light goes on.
should we go through and do pros and cons?
Might be worthwhile.
Or is this the kind of thing where maybe we should just test all of these options? Like work them out, like break into a group and like work out what we would need to do to test it?
Or you said the pressure variation in the pipes is 0.5 psi
To 60
to
psi.
60. Jeez.
And that's just the pipes that we've been working on.
Don't be standard. Okay.
So that's one of the many reasons why this is a hard problem. So that's why I want to step this down so that we don't ever like pull the gas out of the pipe faster than the leak would normally be. So should we break into groups to look at these 3 possible methods and sort of try to come up with some of the questions, the experiments that need to happen, the products associated?
A next steps list?
Yeah.
First of all, they can control the input pressure, so they can control the pressure draw, and there is alternative resistance in the soil. So in order to do that, you would have to really crank up the pressure.
I don't know. I don't know if I'm even in the right ballpark.
I think there's so much resistance.
If there's
in the
enough
soil.
resistance, it's not a practice, then I don't care. But if it is, if
I
you're
mean,
close,
maybe it's dry sand, but the other thing that's going to happen is where you have a leak, you're normally going to have some diffusion through the soil, or there's going to be finding whatever the path of leak resistance is. And then you introduce a vacuum, and you're going to want to draw the gas towards that, whether the leak is here or it's over there.
Right. So maybe the distance between the leak and our drill hole doesn't matter. And maybe it does. Sorry, I made it.
what is clear about all this this, is this is all eminently tested.
Yes.
This is all experimental research and try it, but it doesn't sound like you have a lot of research.
12 feet.
That's a puzzle.
So there are like the gas technology institute and stuff like that that test, you know, there's a Montreal Research Institute.
And they have a buried pipe under the ground, you can turn the valve flow and.
But that costs money to get in that place and test things. And,
Montreal.
whereas, you know,
Montreal.
small problem.